Hello again, everybody, and welcome to this third video about the chapter Equilibria. During this one, we will be taking a look on the method of the calculation of the pH of a weak acid. So, as we said before, that weak acids are dissociated only to small extent, which means that the dissociation in water is not complete. And we said that we refer to them by an equilibrium. So, once we have an equilibrium, this means that we cannot use directly the value of H plus ions to calculate the pH. So this is why we introduced an equilibrium constant called the acid dissociation constant. We refer to it by the term Ka, and it will be equal to the concentration of the products over the concentration of the reactives, which means the concentration of H plus ions times the concentration of the attenuate ion over the concentration of attenuic acid. Actually, for the attenuic acid, its dissociation constant is equal to 1.74 times 10 to the power negative 5 mole per decimeters cubed, which is a very low value. This means that this acid is slightly ionized in water. Then we can say that an acid will be completely ionized if its Ka value is, for example, equal to 40 mole per decimeters cubed. Now, once the values of Ka are very small, we introduced another constant which is called pKa and which is equal to negative log to the base 10 of the value of the Ka. Let's see now how to calculate the acid dissociation constant for a weak acid. We can see that each acid molecule is dissociated to give one H plus proton and one A minus conjugate base. This means that we can write that the concentration of H plus ions is actually equal to the concentration of A minus ions by taking into consideration the fact that the H plus ions which are produced from the dissociation of water are so small, which means that we will be ignoring the H plus arising from the dissociation of water in front of the H plus ions which arises from the dissociation of the acid. So after that, we can write the equilibrium constant, which is equal to the concentration of H plus ions times the concentration of A minus ions over the concentration of the acid. And by replacing the concentration of A minus ions, we can write that Ka is equal to the concentration of H plus squared over the concentration of the acid. And actually here, in a way to calculate the value for Ka, we will be taking into consideration two assumptions. The first one is that we will be ignoring the concentration of hydrogen ions which are produced by the ionization of water, which means that we will be taking into consideration only the hydrogen plus ions which are produced by the acid. This is for the first assumption. Now for the second one, we will assume that the ionization of the weak acid is so small, which means that we'll be assuming that this weak acid will be dissociated in a very low extent. This means that the concentration of the acid at the end of the reaction will be equal to its concentration at the beginning of the reaction, which means to the concentration of the original acid. So this is by taking into consideration these two assumptions, we can calculate the value of Ka. Let's see now an example on how to calculate the Ka value for a weak acid. Let's take this example. Calculate the value of Ka for methanoic acid. We have here a solution of 0.1 mole per decimeter, and we have the value of its pH. So the methanoic acid, from its name, methane, which means it's containing only one carbon, it's a carboxylic acid. So formula is like this: COOH, and here we have hydrogen. Actually, this is the simplest carboxylic acid. So we can write it as HCOOH. Good. So this is a weak acid. Its dissociation in water will be written as so: HCOOH. This is our acid. We will be having an equilibrium because a weak acid, which will be dissociated, giving proton to give the H plus ion plus HCOO minus conjugate base, or this is called the methanoate ion. Good. So the first step to do here is to write the Ka. The constant Ka will be equal to the concentration of H plus ions squared over the concentration of the acid HCOOH. Now we will be converting the value of the pH into the concentration of H plus ions. By applying formula, we know that H plus ions concentration is equal to 10 to the power negative pH, which means will be equal to 10 to the power negative 2.9, which is equal to 1.26 times 10 to the power negative 3 mole per decimeters cube. So now we found the value of the H plus ions which will be injected in our formula. And for the concentration of the acid, it's already known. It's equal to 0.01. So now we can calculate our Ka value. And the Ka will be equal to 1.26 times 10 to the power negative 3 over 0.01, which is equal to 1.59 10 to the power negative 4 mole per decimeter cube. And this is how to calculate the value of Ka from the value of the concentration of the acid and the given value of the pH. So for the calculations of the pH of weak acid, we can do this by calculating the value of H plus ions. And to do that, we need to know the concentration of the acid and the value of Ka for the acid. In this work example, the question here is calculate the pH of 0.1 mole per decimeter ethanoic acid, given the value of its Ka. Ethanoic acid is containing two carbons. So its formula will be written as so. We have COOH. This is the carboxylic acid functions, and we'll be adding carbon atoms. So its formula can be written as CH3COOH. And actually it's a carboxylic acid and it's a weak acid. So the equilibrium equation can be written as so. We have CH3COOH, which will be in equilibrium with CH3COO minus, this is the ethanoate ion plus H plus ions. From this equation, and by taking into consideration the two assumptions, we can write the equilibrium constant. Ka will then be written as the concentration of H plus ions squared over the concentration of the acid, CH3COOH. Good. Sorry, here I missed a square. Okay, the concentration of H plus squared. Now let's rearrange this equation to find the concentration of H plus ions. So from this equation, the concentration of the H plus ions will be equal to the square root of Ka times the concentration of the acid, CH3COOH, which will be equal to the square root of 1.74 times 10 to the power negative 5 times 0.12, and this is equal to 1.32 times 10 to the power negative 3 mole per decimeters cube. Now we know the concentration of H plus ions. We can now calculate the value of the pH. pH is equal to negative log to the base 10 of the concentration of H plus ions. So it will be equal to negative log to the base 10 of 1.32 times 10 to the power negative 3. And this is equal to 2.80. Good. So this is all about the calculation of the pH of a weak acid. I hope this is helpful for you, and thank you for watching. Don't forget please to share, like and subscribe, and till next video.